In this short video, I'd like to go over an example that came in from a student applying the second derivative test. Now, the first thing to understand about the second derivative test is that the second derivative test is looking at whether a critical number is going to give us a maximum or a minimum. Now, you're correct in thinking that the beneficial piece of the second derivative is to give us information about the concavity. Is it concave up, concave down? Or is it neither, in which case it's maybe an inflection point? The second derivative does tell us about concavity, but the second derivative test isn't using the second derivative to determine concavity. The second derivative test is being used to determine, is a critical number going to give us a max or a min? Here's the second derivative test. If we have something that is concave up, so the second derivative is greater than 0. So let's graph this part of the function. This is concave up because the second derivative is greater than 0, right? If we've got something that's concave up, or in other words, the second derivative 0, and we've got some critical number c, and we could write the ordered pair of that as x equals c, y equals f of c, right? There's our ordered pair. But we know that this point at x equals c is a critical number, and we're just trying to determine, is it a min, a minimum value, or is it going to give us a maximum value? Is it a local minimum at C, or is there a local maximum at C? Well, by looking at the concavity, we can say that because it's concave up, if this is a critical number, then it's going to be a minimum, right? And you can see that from the graph when we jot something down that's concave up. What if we jotted something that's concave down? So in other words, the second derivative is less than 0. If the second derivative is less than 0, and we know that this c is a critical number, then we can tell from the second derivative test that that is going to be a maximum. And if you just do a little sketch, it makes perfect sense, right? So there are some things in math that when you step outside of reading the text and trying to understand the symbols and the wording, if you can just step outside of that and think about what it's doing, it makes a lot of sense. And I think the second derivative test is one of those cases where if you could think about, what does this mean? It means that if we have a critical number on an interval that's concave up, then that critical number, if it is a max or min, it's going to be a min. If we have a critical number, C, on an interval that is concave down, and we're trying to determine, is it a max or a min, it's going to be a max, right? And that's all that it is. So this example that came in from a student, I think the issue with this question isn't actually working it out, but I think that the issue is thinking through, how do we use this second derivative test? There are other ways to determine if a critical number is a max or a min. So how do we use the second derivative test to do that? Well, let's walk through this example. And the first thing we're going to do is locate the critical points. To find the critical points, we're going to use the first derivative, set it equal to 0, and solve, right? And I think that most of the students at this point are able to do that without too much difficulty. Let's go ahead and do it though. We could factor this, 3x squared minus 12x. Oh, and I didn't say this, but what I've already done is evaluated the derivative, the first and then the second derivative, right? So the first derivative, 3x squared minus 12x. And when I set that to 0 and factor, I get 3x times the quantity of x minus 4. I can double check that with FOIL. 3x times x is 3x squared. 3x times negative 4 is negative 12x, so it looks like my factoring is good. And then I can set each of these factors to 0. to get that x could equal 4 or x could equal 0. And those are our two critical numbers. I've used the first derivative to calculate the critical numbers. Part 1 is done. I found the critical numbers. Now I want to show that I can use the second derivative test to determine if those critical numbers correspond to a max, min, or neither. So now I'm going to use this second derivative test. How do I do that? I find the second derivative, and now I've got to see when is that second derivative positive or negative or neither, right? So if I do a little number line here, and I'm looking at this second derivative and seeing when is it 0. Let me keep this color coded nicely so that you can follow along. If I set the second derivative to 0, I get x equals 2. And so if I plop that x equals 2 on a number line, and then I find some test points to the left and right, you know what I'm going to do? I'm going to use my 0 and my 4. I'm going to plop those critical numbers down. And I can see that the 0 falls before the x equals 2, and I can see that the 4 falls to the right of the x equals 2. And if I test the second derivative, 6 times 0 minus 12, that's going to give me a negative value, negative 12. So I know that on this interval from negative infinity up to 2, we're concave down. On this interval, the second derivative is less than 0, so we're concave down. If I put a 4 in, let's see what happens. We get 24 minus 12, which is positive. So on this interval from 2 to infinity, we're concave up because the second derivative is greater than 0. Now that's just applying the second derivative to determine concavity, but now let's use the second derivative to determine if our 0 and our 4 is a max or a min. Now when we're concave down, that point is a max, right? So what does that tell me about 0? Our critical number 0, that's going to correspond to a max. Well, how do I know it's corresponding to a max? Again, it's because the second derivative was negative. It was less than 0. So that gives us a maximum. When we're concave down, the critical number gives us a maximum. Here it is. Let me highlight it on here. Oh, sorry, it's not a highlight. If you want to just memorize it, I hate encouraging students to learn mathematics by memorizing, right? Because you can't possibly memorize everything and recall it effectively. But if you want to practice with just using it as it's written, when the second derivative is less than 0, what do we get? A maximum. But so much better if you understand it, right? And how do you understand it? Picture this concave down piece, and it's obvious that that value C, if it is a critical number and we're trying to determine is it a max or is it a min, it's got to be, out of those two, it's got to be a max. And then on this other one, what we could see if we had a little sketch here of something concave up, just by reason I can see that if this critical number is something, it's going to be a min. So this critical number of 4, critical number 4 is going to relate to a minimum. But let me show you just by the reading the figure here, or by reading the theorem. If the second derivative is greater than 0, or in other words, it's concave up, and we have a critical number on that interval, then that critical number is going to be a minimum. So the second part of this question, use a second derivative test to determine whether the corresponding local max, or determine whether the critical numbers correspond to a max or a min. What I'm going to say is that 0 corresponds to a max. And I think the way that this pops up on my lab math is that it asks for the max first. So the max is going to be 0, and then it's going to pop up and ask you for a minimum. And we can see that the 4 corresponds to a minimum. Well, I hope that this short video has cleared up any misunderstanding you had about how to apply the second derivative. And thanks so much to the wonderful student who sent the question in.